So last winter, I felt like I was always trying to manage the valve on the fireplace. So this winter, I thought I'd be ready and make an actuator that would automatically control the valve for me. So when that fire got hot, it's going to reduce it to like an operating level. And when you're trying to get the fire started, it's going to leave it open all the way. And I probably will add a real-time clock chip so that at night it just closes it down and saves the firewood. So to start this project, I picked up some $25 actuators. They're 10 inches actuation, and they came with a DC motor. And they had diodes on either end of the micro switches. So I desoldered and soldered the wires straight to the micro switch, as I wanted to use this as my homing switch for a stepper motor. In this picture you see I used part of the shaft of the DC motor and drilled out a coupling and adapted that to my stepper motor for the mechanical part. I reused the one housing, the end housing for the DC motor, and I 3D printed a little adapter to go around the coupling that I made up. Next up, we start doing a little breadboard work. I started with the Adafruit stepper motor driver. I thought that was a good solution since it just used I2C, but I ended up having a little trouble with it, and I found that I preferred to use the Max TMC 2208 stepper motor driver since I could control it with low-level square waves. This one also gave me the benefit of interpolating the square waves and making pretty much a sinusoidal wave, and it was much quieter driving the stepper motor. Most of the 3D printers these days seem to be coming with the same driver, but they're controlled by a UART rather than the step and direction pins like I'm using. So here's in the breadboarding phase with the Adafruit driver and the TMC 2208 driver at the same time, and I was trying out the two different ones. Right now the display is showing the position, so the number of steps, but later in the code I mapped that from 0 to 100, so you'll see like how many percent closed the fireplace valve is. In the previous video I just showed a BBB from Modern Device, and here is an RBB also from Modern Device, and I'm going to a solderable breadboard, and you can see the TMC 2208 and the Max 31855K type thermocouple amplifier. It also has the advantage of having an internal temperature, so I get 2 for 1. Okay, so here's where I'm at now. I used some T-slot. I used the original brackets over here. Here's my 3D printed housing, coupler I made. And for now, the screen's up here, but I think I'll add a place for it on the 3D printed case. So this is my night mode for now until I add a time chip. And this is the motor enable. So it's initializing. It moves. After it initializes, then it just backs up a bit, so it's ready. And there we go. Shows valve is closed, 0%, so it's completely open. The chip temperature is 24, and the thermocoupler, or the fireplace, is 30 degrees. Which seems a little warm, but it's still cooling off, probably from when the fire was on. So at this point, I think I have a fireplace where I can just add the wood, don't worry about the temperature. The valve will open and close, keeping it right at the proper temperature for the chimney and optimal burn. And at night it'll automatically close, and in the morning it will automatically open, and save me some wood and just relax. Don't need to worry about the fireplace as much.